Dear students, in our previous class, we have discussed about mean terms and the steps involved in mean term expression expansion. It means expansion of mean term expression. These things we have discussed and we have solved the problem on this. Today, we are going to discuss about the shorthand mean term notation. Shorthand mean term notation. What is this shorthand mean term notation means? The shorthand mean term notation means, listen here, since all the letters, okay, two in case of two variable expression, three in case of three variable expression, okay, must appear in every product, okay. In previous class I have explained you regarding this thing. If I take x plus y as one expression, okay, think this as one expression. Here two, since all the letters, it means two letters in case of two variable expression. Here two variables are there, but both are different variables. So these two variables must be present in every product. Must be present in every product. Okay, two variable in case of two variable expression. Two letters must be present at every product. Okay, then three in case of three variable expression, AB plus BC plus AC. Okay, this is a three variable expression, or we can write down this like this: AB plus C. See, it is expression but contains three variables A, B, and C. So, if an expression is containing three variables, then rule is that all the letters, okay, it means A, B, and C, all the letters must be present or must appear in every product. Means all, this is first product AB, okay, then C is the second product, then all the three variables must be present in every product. Okay, three variables present here and three variables present here. So this is the rule of shorthand mean term notation. Every product. Okay, so what is the use of the shorthand notation? Shorthand mean term notation has been developed. Okay, shorthand mean term notation has been developed. What's the use of this? That saves, okay, that saves actually writing the letters themselves. Okay, look here. As you know that all the letters must be present in every product, either in first product or in second product. So shorthand mean term notation has been developed. Shorthand mean term notation has been developed. For what it has been developed? Has been developed to save, okay, writing the letters themselves. Means to save by writing these letters as it is, to avoid by writing the letters as it is. Okay, we will discuss later how we can change these letters into shorthand min-term notation. Then you come to know the letters will not be written as it is. Okay, it says the writing letters themselves. To form this notation, to form this notation, to form this notation, we need to follow these steps. We need to follow these steps. Okay, what are the steps? Okay, it is min-term notation has been introduced to avoid the writing of letters as it is. Okay, to avoid the writing of letters themselves. So to get the min-term shorthand notation or shorthand min-term notation, we need to follow some steps. Okay, here now after this I'm going to write some steps. So by those steps you will come to know how the min-term notation can be represented for an expression. Now we shall see the steps. Okay. I will take one min term here. X, Y bar, Z bar. Okay, shorthand min term notation. Shorthand min term notation. I will take one expression here. X, Y bar, Z bar. It is an expression. Okay. First step, what we have to do? We have to write down the expression as it is. First of all, copy the originals. Copy the original items. Copy the original items. Okay. Here X, Y bar, Z is there. Copy as it is. X, Y bar, Z bar. Okay. Copy as it is. Next, what we have to do? Okay. Second step is substitute each zeros. Sorry, do like this. Substitute zeros for every barred letter and ones for every unbarred letter. Okay, substitute 0 for every barred letters and 1 for every unbarred letter. As you have already know that mean term. Okay, how can we express the mean term? We can express mean term by writing 1 in place of unbarred item and 0 in place of barred item. Barred means complements. This is the rule of mean term. Substitute 0 for every barred letter and ones for every non-barred letter. Here first X is a non-barred letter. Here there is no bar for X. So substitute 1. Okay. In place of X, I will put 1. Okay. Then substitute zeros for every barred letter. Okay. 2 bars are there for both of the letters. Bars are there. For that, I will write 0 here in place of Y, and in place of Z, I will write 0. Then the third step and the last step, what we have to do, express decimal place, express the decimal the decimal equivalent, the decimal equivalent of binary word, as a subscript, of m, as a subscript of m. Here small letter m we will use. Okay, for min terms we will use the small letter. Okay, express the decimal equivalent of binary word as a subscript of m. Look here. Here we have to do like this. 1 is there, so write down 1 into 2 plus 0 into 2 plus again 0 into expand using decimal number system. Okay, here this is in 0 place. Okay, 2 to the power of 1, then 2 to the power of 2. Okay, is it right? 2 to the power of 0, 2 to the power of 1, then 2 to the power of 2, which is equal to 1 into 4 plus 0 into 2 plus anything to the power 0 is always 0. Anything to the power 0 is always 0. Remember this. So 0 into 0, which is equal to 4 plus 0 plus 0, which is 0, which is equal to, the answer is 0. So the shorthand notation of x, y bar, z bar will be written as m4. Will be written as m4 because the value we have got is 4. So we will going to express this as m4. Thus x, y bar, z bar is equal to m4. We have got the value 4, so we will represent. Okay, look here, express the decimal equivalent. Okay, decimal equivalent, this is 0 to 9 is decimal. Okay, equivalent of binary word. Okay, of this binary word, decimal equivalent is 4 of binary word. Okay, binary word as a subscript of m. Subscript means right below m, that is called subscript. So the shorthand minterm notation for x, y bar, z bar is m4. Thus x, y bar, z bar is equal to m4. First what we have to do, first of all copy the original items, then substitute zeros for every barred letter and ones for every non-barred letter. Okay, then express the decimal equivalent of a binary number. Okay, as subscript of m. Okay, express the binary equivalent. Binary means 0 to 9. Sorry, express the decimal equivalent. Decimal means 0 to 9. Okay, then decimal equivalent of binary number. This is binary. Zeros and ones is a binary number. Decimal equivalent of binary number as subscript of m. Subscript means below the m letter, just beside we have to write the subscript. So like this we can express or we can denote the min term in shorthand. So earlier what we have discussed, okay, shorthand min term notation has been developed that saves actually writing the letters themselves. Okay, here letters are there. This will save writing the letters themselves. Here we are not writing the letters as it is. We have founded the value of these letters, then we will write the value of the letter as subscript of m. That is called saving, saving that writing letters as it is. So we have got m4 as the shorthand min-term notation for x, y, or z. So for your understanding purpose, I will take one more expression and I will try to solve. Look here. A B bar, then C D bar. First, what we have to do, first of all, okay, copy the original items. I will copy the original items. A, B bar, C, D bar. Okay. Then substitute zeros for every barred letter and ones for every unbarred letter. Okay. Zero for barred and one for unbarred. In place of A, 1. It is barred, so I will write 0. C is unbarred, 1. D is barred, write 0. Okay, then express the decimal equivalent. We have to derive the decimal equivalent. 1 into 2 plus 0 into 2 plus 1 into 2 plus 0 into 2. Okay, here 1 into 2, 0 into 2, then 1 into 2, then 0 into 2. Here from here 0, 1, 2, which is equal to, okay, 2 cube means for 2 cube. Okay, what we have to do, 2 into 2 into 2. Okay, which is equal to 2 2s are 4, 4 into 2. Okay, 2 2s are 4, then 4 2s are 8, which is equal to 8. 1 into 8 plus 0 into 2 power is always 4 plus 1 into 2 plus, okay, 0 to the power anything is 0, 0 into 0, which is equal to 8 ones are 8 plus 0 into 4 is 0 plus 1 into 2 is 2 plus 0 into 0 is 0, which is equal to 8 plus 2 is 10. This is equal to M10. Okay, look here. Therefore, A B bar C D bar is always equal to M10. Okay, this is min term we are solving. So for that we will use the small m. We will not use the capital M here. We will use the small m here. Like this, we have to denote the shorthand notation. Okay, we can get the shorthand notation of any expression. Okay, right? Okay, what we did, express the decimal equivalent. We have got the decimal equivalent then of a binary word. This is a binary word. Okay, as a subscript of m. Okay, write it as subscript of m. Like this, the shorthand notation of min term can be denoted. Now, this finishes about min term. So now we are going to discuss about the max term. Max term. What is meant by max term? So first we have to go back. We have to recall the mean term. Mean term means okay, the product of all the literals with or without bar within the logic system. The product of all the literals, okay, is mean term. Here max term means the sum of all the literals. The sum of all the literals, the sum of all the literals with or without bar. Okay, with or without bar within the logic system. Within the logic system. Within the logic system. This is called max term. Okay, for your understanding purpose, I will write min term here. Min term. Okay, the product of, okay, the product of all the literals, the product of all the literals with or without bar, with or without bar within the logic system. within the logic system. Here we need to understand something. Here I will underline two words, sum and product. Okay, this is max term. Okay, sum of all the literals, product of all the literals. Here sum of all the literal means x plus y plus z. This is called max term because sum means addition plus. So sum of all the literals is a max term. Then product of all the literal means x, y, z, the multiplication. Okay, this is min term. Okay, and this is max term. Sum of all the literals. Here three literals are there. We are adding sum. Sum of all the literals is max term. Then min term means product. Product means into. Okay, so the product of all the literals is min term. Here one condition is there, with or without bar. We can, if we want, we can add bar anyway. If the literals are the barred literals or without the barred literals, whatever they may be. Okay, the sum of all the literals with or without the bar within the logic system is called as max term. The product of all the literals with or without the bar within the logic system is called as min term. Now we are discussing about the max term. Here one logic is there. If you are trying to be logical, okay, in a logic. So one logic is there. If something in an expression okay, is called as max term. So we will take first min term. Okay, is called as min term. Is called as min term. There always one which is called as max term. Okay, in an expression, if min term is present, okay, if something in an expression is called as min term, if a thing in an expression, write one expression x, y plus z plus w. Okay, in an expression, if something is called as min term, this is min term because the product of literals, then there always one called as max term. Then always one thing is called as max term. This is the product of two literals. This is the sum of two literals. Wherever we write the expression, in that expression, if any min term is there, then surely there must be a max term is present. So how can we express this max term? I'll take the same example. I will take the same example which I have taken in min term here. Okay, here I will take three variables: x equals 0, y is equal to 1, z is equal to 1. And x is equal to 0, y is equal to 1, and z is equal to 1. Okay, so how can we express this? Here, for every one, we need to put a bar. Okay, for every 0, we will write the variable as it is. Okay, plus, because this is max term, so we are doing addition here. Y bar plus z bar. Okay, this is max term. For min term, okay, we will write bar for 0. Okay, x bar, y, z. Okay, for min term, we will put bar in place of zeros. Okay, and we will do multiplication, that is means product. If for max term, we will put bar in place of 1 wherever there is 1. So we will write bar in that place for max term, and we will put a plus sign, a or sign in between the literals. This is called max term, and the difference between min term and max term is this. If any expression contains the literals with or operator, that is called max term. If an expression contains the literals with and operator, that is called min term. So the product of literals, and this is the sum of literals. Okay, the same way I will take one more example for your understanding purpose. Okay, x is equal to 1, y is equal to 0, and z is equal to 0. Here for max term, in place of 1, we will put bar. In place of 0, we will just write down the variable as it is. Sorry, right here plus y plus z, because this is max term. For min term, in place of 1, we will write as it is, and in place of zeros, we will put the bars. This is the difference between the min term and the max term. Okay, now we are going to write how can we, which is the letter we will use for the expression of max term. Okay, in min term we have used m small letters, but in max term we have used m capital letter. Capital letter we will use. Okay, earlier we have did m4 and m10 like that. This is for min term and this is for max term. Okay, we will write small letter m for min term and we will write capital letter M for max term. So this is a short explanation about max term and min term. So you may get questions like this: what is min term or what is max term? Or how can you express a min term or how can you express a max term? Okay, or some expressions can be given and they will ask you to represent these expressions in min term or in max term. So at that time you can represent those expressions in min term. Simple way. Here expression is given. Okay, expressing min term and max term. Here some values might have given like this. Okay, the same way. X value 0, y value 1 and z value 1. And question will be asked, express these variables, okay, or these literals in min term and in max term. Then just you have to do is write down their expression. X is equal to 0 means put x as it is in max term. Y is equal to 1 means put a bar, plus put a bar for y. Okay, plus if z is equal to 1 means put a bar for z. This is for max term. For x is equal to 0 in min term, put bar on x. Then this is min term, so we will do AND operation here. Y put as it is, z put as it is. In min term, the variable containing 0. In max term, the variable whose value is 1, put bar for those variables. Like this, you can represent the min term and max term. Now come to canonical expressions. Okay. Canonical expression. Okay. What is meant by this canonical expression? Canonical means what? What is meant by canonical expression? So here, Canonical expression means Boolean expressions. Boolean expressions composed entirely, okay, entirely, okay, either in min terms, okay, or in max terms, or in max terms is referred to as canonical expression. Isn't it? This is canonical expression. You need to understand this canonical expression. It is very important for the next processing of your and further movement of your chapter. Okay, for that you need to understand this. What is canonical expression? Canonical expression means any Boolean expression or the Boolean expressions composed. Composed means to writing or written is called composed. Okay, Boolean expressions composed entirely means completely. Okay, completely, either in min terms or in max terms. The expression which is written completely either in min terms or in max terms is referred to as canonical expression. I will give you the example for this. First, I will take min terms. What is min term? It is a product of the literals. So here x, y, z plus x bar, y, z plus x, y bar, z. Okay, see, this is product of the literals. Okay, this is called product. One product x, y, z, x bar, y, z and x, y bar. Three are the different products. Okay, this is called the min terms completely written in min terms. Okay, this is the expression that is completely written in min terms. Min term means product means multiplication of the literals. Think this as one literal, individual literal. Three literals are what? Product, the product of three literals, and this is the product of three literals, this is the product of three literals. This type of expression is called as canonical expression. Okay, this is for min term. What for max term? For max term is x plus y bar plus z plus w. Look here, max term is composed entirely. What is meant by max term? Max term means the sum of all the literals. The sum of all the literals. Sum means or operator. Okay, product means and operators between the literals. So this is sum of all the literals. Okay, composed entirely in max term. Okay, the expression is completely in max term. See, no product in between this, no and operator in between this. This is called canonical expression of max term, and this is called canonical expression of min term. So completely the canonical form means, okay, Boolean expression composed entirely either in min terms or max terms is referred as canonical expression. Here in between this thing we should not use the max terms. Okay, and in between max terms we should not use the min terms. That is the meaning here. Hope you have understood this canonical expression. In canonical expression there are two types. There are two types of canonical expressions. Two types of canonical expression. Types of canonical expressions. Okay, the first one is sum of product. Sum of product, that is, it means, in short, this can be called as SOP, because from S this is sum, for O of, for P product. The second one is product of sum. Product of sum, this can be written as POS. Okay, this is bracket, don't get confused. POS, from P product, from O of, then from S sum. Okay, sum of product SOP, product of sum POS. We can also, okay, pronounce this as SOP or POS. SOP or POS, then SOP or POS. First, we are going to discuss about sum of product. Okay, what is meant by sum of product? Okay, sum of product means a logical variable or expression. A logical expression is derived from two sets of known values, from two sets of known values. A logical expression is derived from two sets of known values. What this mean? Any logical expression, it can be derived from two sets of known values. I will take x and y. Okay, the x value is 0 and y value is 1. Okay, and I will take one more variable z. Okay, if we do x or y, x plus y, then the answer will be 1. Okay, if we do x and y, okay, then the answer will be 0. This means a logical expression z, okay, is derived from, okay, value of z is derived from two sets of known values. Here, two sets of known values. That is called the sum of product. What are these two? Here it contains mainly 2 points. Okay, the first one is, what are these two sets? Okay, we need to discuss what are these two sets. First one is various possible inputs. Various possible inputs. First thing is what? Various possible inputs. The second is the derived output. The desired output value, the desired output values from each of the input combination. From each of the input combination, various possible inputs, any number of input it desire. Okay, we can give various inputs. The first thing, the desired output, okay, required output, okay, required output value from each of the input combination. From this is one combination, like that several combinations may be there. Okay, the desired value, what the result or what the output has to come if we getting same output from each of the input combination. That is called sum of product. Okay, hope you have understood these things. Now we are going to, I am going to explain the sum of product by giving an example for you so that you can understand this clearly. Let us consider a specific problem. Consider a problem. It contains two variables, x and y, and the output as said. Okay, consider an expression which contains two variables, x and y. They are inputs. Okay, and output as z. Output is z. So here some conditions are there. As we create truth table for AND operator and OR operator, the same way here also some conditions are there. Okay, look here. If x is equal to 0 and y is equal to 0, then z is equal to 1. Z is equal to 1. This is the condition of SOP form. Okay, sum of product, first one. Okay, this is the condition. If x is equal to 0 and y is equal to 1, then z is equal to 0. Okay, this is not as AND or operator. This is entirely different because it is sum of product. Then if x is equal to 1 and y is equal to 0, then z is equal to 1. If x is equal to 0, y is equal to 0, 0 we have taken. If x is equal to 1 and y is equal to 1, then z is also equal to 1. Look here, x 0, y 0, then the output is 1. Okay, x is input, y is input. Then output is z. So x value, two inputs we are giving as 0, then z is 1. If x is equal to 0, y is equal to 1, then z is 0. If x is equal to 1, y is equal to 0, then z is 1. If x is equal to 1, y is equal to 1, then z is 1. Here, the condition is that only when x is 0 and y is 1, only at the time the z will be 0. If x is 0 and y is 1, only at the time the z is 0. Now, based on this thing, we are going to create a truth table for this. We are going to create a truth table for this. Take two variables x and y. X, y. Whenever there are two variables, then how many values we have to take? We have to take 4 values. 0, 0, 1, 1. 0, 1, 0, 1. Okay, these are 4 values. Like this we have to take. 2 inputs. One is output. What is that output? Z. Z is the output here. So then, what is the rule of SOP? If x is 0, y is 0, then z is 1. Okay. If x is 0, y is 1, then z is 0. Okay. If x is 1, y is 0, then z is 1. Okay. If x is 1, y is 1, then z is 1. If and only if when the value of x is 0 and y is 1, at the time only the answer will be 0. Now write the product items for this. Product item. How will you write the product items for this? How will you write the product items for this? So the product item for this is, we have to write the variables for these values. Okay, for min term, because it is sum of product. Sum of product is always min term. Okay, sum of product is always min term. So for min terms we have to write x value 0. So for every 0 value we have to put a bar in min term. Okay, y value 0. So we have to put bar. Okay, Then x value 0, we have to put bar. Then y is 1, no need to put any bar. Write down as it is. Then x is 1, no need to put any bar, write down as it is. Then y is 0, then you have to put a bar here. Okay, then x is 1, write down as it is, y is 1, write down as it is. We have got the product items. Okay, we have got the product items. Now, how will you write the SOP form for this expression? Okay, how will you write the canonical sum of product? Okay, this is sum of product. Then how will you write the canonical sum of product? Canonical sum of product. Okay, canonical sum of product. We need to write plus. Okay, plus. Then here 0, no need to write. 1 is there, x, y bar. X, y bar plus here 1 is there, result is 1. Then write down this x, y. This is called as canonical product of sum. Okay, canonical form. We have discussed. What we have discussed? Since all the letters, okay, must be appear in every product. So here two letters x and y, x and y, x and y, x and y. All the letters are present in every product. So this is the canonical form of SOP. Canonical SOP form. Canonical SOP. Like this, we have to write the canonical SOP form. Okay, hope you have understood this. So, what is this canonical SOP form? Okay, we need to understand this canonical SOP form. Hope you have understood this. I will leave table as it is and I will rub this side items. Canonical SOP form. Okay. Canonical SOP form. When a Boolean expression is when a Boolean expression is represented purely in min terms, purely in or purely as sum of min terms, sum of min terms is called canonical SOP form. That is canonical sum of product form. When a Boolean expression, okay, is represented purely as, okay, purely as sum of min terms. Min term is product of literals. Okay, this is the product of literal, product of literal, product of literal. It is asking sum of min terms. Okay, product of literal is a min term. This is one min term, this is one min term, this is one min term. Sum of min terms means a min term is added and a min term is added with another, just like the sum of min terms. In between every min term, whenever there is an or operator, okay, in between every, when there is an or operator, okay, that is called as canonical SOP form. Now we shall discuss, or we will try to get a result or to get a canonical SOP form for 3 variable expression. We have solved for 2 variable expression. Now we will try for 3 variable expression. Here for 3 variable expression, Okay, if x is equal to 0, y is equal to 0, z is equal to 0, okay, then f is equal to 0. Okay, if x is equal to 0, y is equal to 0, z is equal to 1, then f is equal to 1. If x is equal to 0, y is equal to 1, z is equal to 0, okay, then f is equal to 1. If x is equal to 0, y is equal to 0, then sorry, y is equal to 1, then z is equal to 1, then f is equal to 0. If x is equal to 1, y is equal to 0, z is equal to 0, then f is equal to 1. If x is equal to 1, y is equal to 0, z is equal to 1, then f is equal to 0. If x is equal to 1, y is equal to 1, z is equal to 0, then f is equal to 0. Okay, if x is equal to 1, y is equal to 1, z is equal to 1, then f is equal to 1. Now you need to understand this thing. How we have got zeros and ones here for the result here. For result, I have taken it as f, and these are the three variables. Here, I will not explain in difficult form. I will make you easy. Wherever two zeros are present in three variable expression, and wherever the complete expression has 1, only in that place 1 will come. Here look, x is 0, y is 0. If two are zeros, okay, then f is 1. More than 2 means, if 3 zeros means, here it will become 0. X value 0, z value 0, f equals 1. Okay, then here y value 0, z value 0, then f is 1. Okay, here, and last, x1, y1, z1, f is 1. Okay, like this for 8 variable expression, 3 variable expression. Now we are going to write a truth table based on this. Okay, wherever there are only two zeros, either there must be only two zeros, or the complete expression is 1. Here only two zeros are there, third is 1, then 1. Here two zeros are there, then 1 is 1, this is 1. Here two zeros are there, 1 is there, so 1. Here all the three variables have values as 1, then f is 1. Okay, x value 0, y value 0, z value 1, 1. X value 0, y value 1, z value 0, 1. Okay, x value 1, y value 0, z value 0. It is 1. Then at last all the three variables contains value 0, then it is 1. Now I am going to write the truth table for this. X, y, and z. You have already know that for three variables, okay, expression, we have to take 8 values for every expression. 1, 2, 3, 4, then 5, 6, 7, 8. Here, half of x, 0, 0, 1, 1. Here, half of y, 0, 1, 0, 1, 0, 1, 0. Okay, for this result is f. Result is f. Result is f. Here 3 are 0, so write 0. Here 2 zeros are there, so write 1. Here 2 zeros are there, write 1. Here only one zero is there, so write 0. Here two zeros are there, write 1. Here only one zero is there, so write 0. One zero is there, write 0. All are 1, then write 1. Like this, you have to create a truth table for SOP form. Okay, this is SOP. Now from SOP, we are going to derive the canonical SOP form. Okay, then product item, okay, or min term. Product item or min term. We can call it as product item or min term. Okay, for min term, in min term, for zeros we have to put bar. Okay, x bar, y bar, z bar. Okay, then here two, for two values, leave f because this is result. Okay, don't take this, don't count this thing, just take the three variables. Okay, x y. Okay, then x bar, y bar, z. Here x bar, y value is 1, write down as it is, z value is 0, put bar. Okay, x value is 0, y value is 1, write as it is, z value is 1, write as it is. Here x value is 1, so write as it is, y value is 0, put a bar, z value is 0, put a bar. Here x value is 1, write as it is, y value is 0, put a bar, then z value is 0, write down as it is. Here x value is 1, write down as it is, y value is 1, write down as it is, z value is 0, then put a bar. X value 1, write down as it is, y value 1, write down as it is, z value is 1, write down as it is. As we have discussed in previously, what we have to do means wherever the result is 1, okay, write its min term or product term. Here result is 1, here result is 1, here result is 1, then here result is 1. So write down these things, x bar, y bar, z plus, okay, x bar, y bar, z. X bar, y, z bar, x bar, y, z bar. Then plus y, z bar, x, y bar, z bar, x, y bar, z bar plus, okay, x, y bar, z bar plus x, y, z, x, okay, here x, y, z. So this can be called as the canonical sum of product for three variables. Okay, hope you have understood this. Like this, we have to create a canonical SOP form. Canonical SOP means canonical sum of product form. Like this, we can get canonical sum of product form with the help of truth table. With the help of truth table, what we have to do, first of all, write down the variables as it is. Then create a truth table for the values. Then find the result according to the rules. Then write down the product terms based on the inputs. After that, whenever the result is 1, wherever the result is 1, write down the min terms or the product terms of that result. Then you will get the canonical SOP form. Canonical SOP form means when a Boolean expression is expressed completely, okay, in min terms, in or as the sum of min terms, that is called canonical SOP form. This is by truth table method. Now one more method is there, that is by algebraic method. By algebraic method. Now we shall going to discuss the algebraic method of canonical SOP form. I will take one value here, x bar y plus y bar z bar, x bar y plus y bar z bar. Now we have to get the canonical SOP form. Canonical SOP form is x, y, z must be here, then x, y, z must be here, like that. Any number of literals it may be. Okay, we have to derive it like this. So first write down the literals as it is. Okay, write down the literals as it is. Then apply De Morgan's law. De Morgan's law. What the De Morgan's law states? We have did. Okay, in our previous class. Complement the entire expression. Okay, x bar y plus y bar z bar. Complement the entire expression. Put a bar for the entire expression. Okay, put a bar for entire expression. Okay, we have put a bar for entire expression. Okay, then what will happen here? What will happen? According to involution law, when the complement of a variable is complemented again, then we will get the same variable. That means x double bar is equal to x. Okay, y double bar is equal to y, z double bar is equal to z. So equals. According to this involution law, okay, x double bar is there. X double bar is there. So we have to take as it is. Okay, we'll do one thing. X double bar is there, write x. Okay, x plus, no, see here x double bar is there, so according to involution law this will become x. Here y is there, so only one bar is there, so write down y bar plus, okay, y double bar is there, it will become like this. Then z double bar is there, it will become like this. Okay, like this we have to do. Then what we have to do? Just multiply. Okay, multiply these things. How can we multiply this one by this one? Okay, x plus y. Then just a minute, wait. Yeah. Wait a minute. X y bar plus y z. So we will apply the distributive law for this. What the distributive law states? The distributive law states that, okay, before applying distributive law, we need to add these things. Okay, which is equal to what we have to do. The next step. First step is according to De Morgan's law. First step is complement the entire relation. Okay, entire expression. Then we have got this. Second step is change each or sign to and sign. Then change each on and sign to or sign. Here and sign is there. I will change this and sign to or sign. Okay, here or sign is there, I will change it to and sign. Then put y and sign change to or sign. This is like this. Okay, then according to distributive law, what this distributive law states? The distributive law states that x plus yz is equal to x plus y into x plus z. Okay, distributive law states that x plus yz is equal to x plus y into x plus z. Here, this is x plus y, this is x plus z. Okay, x plus y, x plus z. Then the result is x plus yz. X plus, okay, this is xy. Here, this is xy, means here x plus yz. X we have taken y. Okay, then z. y, z. We have created like this. Okay, then after that, what we have to do, as we did in yesterday's class, put x in place of missing letters, which is equal to, I will write the present x like this. Okay, then x plus x y bar z. Okay, then write the combinations of x, which is equal to x into y plus y bar into z plus z bar. Okay, as we did in our previous class, plus x bar into, okay, plus y bar z into y bar z. Is it clear? Yes. Now we need to expand. First x into what? X into y plus this one. X into y bar. Then write down as it is z plus z bar plus, okay, we have to multiply this. X into y bar z plus x bar into y bar z. X bar into y bar z. Okay, this is algebraic method of proving algebraic method for canonical SOP. Okay, for canonical SOP form is algebraic method. According to De Morgan's law, complement the entire expression. Okay, we'll get this result. Okay, then how we have got involution law. If a complement of a variable is complement again, we will get the same variable. Here, complement of a variable is again complemented. We are getting same variable like that. X double bar is equal to x. Here only one bar is there, so put y bar as it is plus. Then y double bar is there, write y. Z double bar is there, write z. Then change each or sign to and sign to or sign. So and is there, change to or is there, change to and is there, change to or. Then according to distributive law, okay, x plus yz is equal to xy plus xz. Based on this, we have taken the result of this here. Then write x wherever letters are needed, wherever missing letters are there. Here x is present means yz is missing. Here yz is there, x is missing. So in place of missing letters, I will put small x because this x is already present here. So two things are missing, y and z. So we have to write its combination, y plus y bar, z plus z bar. Here x is missing, x plus x bar. Then expand the equation. Okay, we have expanded the equation. Then for your reference, I will write down same thing here. Xy plus xy bar, xy plus xy bar into z plus z bar plus xy bar z plus xy bar z plus x bar y bar z, x bar y bar z. Now, what we have to do here? We have to do one thing, that is add these things with this. Here plus sign is there, so we will add. Okay, x y plus z. Okay, do one thing. In both the things, okay, so here what we have to do is we have to do one thing. Multiply this thing by this. Okay, multiply this thing by this. Z into xy plus xy bar. Okay, plus see z into xy plus xy bar. Then z bar into xy plus xy bar. Okay, write down as it is plus x y bar z plus x bar y bar z. Okay, look here xy plus xy bar. Now multiply by this. Okay, this will become z into xy. First this one, then this will become xyz plus, then multiply with this. Okay, xy bar z plus, okay, here. Now by this xyz bar plus this z bar with this xy bar z bar. Then write down these things plus x y bar z plus x bar y bar z. Now this thing is expanded. So what we have to do? We have to drop the similar items. Okay, we have to check the duplicates. Okay, finally what we have to do? Drop all the duplicates. After expanding expression, we need to drop the duplicates. For x, y, z, is there any duplicate? No, there is no duplicate. So write down x, y, z as it is. Okay, this is finished. For x, y bar, z, any duplicate is there? Okay, for x, y bar, s, one duplicate is there, x, y bar, z. So just write down once, x, y bar, z. For this, any duplicate is there, x, y, z bar? No, there is no duplicate, x, y, z bar. Plus, for this, no duplicate, x, y bar, z bar. Plus, for this one, there is no duplicate, write down as it is. So, we have got the canonical SOP in algebraic method. So I've shown you two methods. One is the truth table method of getting canonical SOP form, and the another method is the algebraic method of getting canonical SOP form. You may ask by any of the expressions that change these expressions to canonical SOP form. So like, but if they ask just they give expression and just they will ask, okay, convert this expression into canonical SOP form, then that is left to you. In any method you can do, either by truth table method or by algebraic method. If particularly asked, convert this expression into canonical SOP form with the help of truth table, then you have to get the canonical SOP form by truth table method. Or question may be asked, convert this canonical expression, convert this expression into canonical SOP form by algebraic method, or convert, you may ask like this, convert algebraically into canonical SOP form, and below that the expression has given. At that time you have to solve by algebraic method. So this is about the shorthand min term notation, then max term. After that, canonical expression in the two types. One is sum of product, another one is product of sum. In sum of product, this is the canonical sum of product. We have stopped here. In next class, I will bring you some more examples. Okay, I will bring you some more examples. We shall solve some more examples of this. If you have any doubt regarding this, you can ask me personally. Thank you.